to this data in. We've got the age and list, and we're going to go through the full regression analysis. All right, so what we're going to do, the first thing, I'm going to follow this here. So I'm going to do it on our calculator with you now. So we've popped in our two lists, age and price. Okay, and the first thing that it's asking me to do is do a scatter plot. So if you remember, we go to the home, so you guys could do this, and we can do a scatter plot. So when we price is what we're predicting, so we'll put price here and age along here. So we get this scatter plot. So then we'd comment on this scatter plot. What do you think? This is a negative? Yes? And I'd probably gonna have a guess that it's strong. Negative, strong, linear. It looks like it's following a straight line, yeah? Linear. So just to go over, we do need the equation of the line when we're doing our regression analysis. And yesterday I talked about you can get it on this scatter plot. So we could press menu, analyze, regression, and you say show the A plus BX. And that's put it there. But I said I didn't really like this one because it has Y and X, and we would never use that. It should be price equals, and there's a negative gradient things. And that also, see how they always write plus minus? That's also, kids write silly things. You don't need to write that. It's actually a negative B value. So that's where you could, where I would like you to get it, and part of our regression analysis is to get the R and the R squared value. I would prefer you get your A and B value here. So we're back on our listen spreadsheets, and we're going to go menu, statistics, stat calc, and we go down to here, linear regression A plus BX. So we've done this, and this is the X list we're going to pick is age, and the Y list was price. So this is why it's crucial to put your list names in, because I've actually got another couple of other lists saved in here, and so I don't want to forget which one is it. So when you do that, now you get all these values here. So if you look, up at the very top is the A value. So the A value is 35,134. And then here's the B value, it's negative. So if you click on it, you can always look down here if they're asking you for, more decimal places that you can't see, it's there. And then if I keep moving down, you've got the R squared and the R. So the R says it's negative 0.96. So this one's very strong, and the R squared is there. So we'll look at that in a minute. All right, so that's how you get this. So if we go back to this analysis, we've done the scatter plot, we've done the correlation, we found the R value was -9, and we've commented that it's a strong negative. Now we've found our equation. Well, we would write that out. So if we were writing, say I'm going to just write it in here, I would say price, if I was writing the equation, price in, say, whatever they said, dollars, oops, where's the dollar symbol, equals, now I'm going to say we don't ever buy a car, you don't really buy it to the nearest dollar or, dollar or whatever, the cents. So what I'm going to do is I'm going to summarize this, I'm going to round my A value here to, I'm going to say to 3 significant figures, because that's going to, be more practical. So here, this A value, what would that be to 3 significant figures? It would be 35,100, yeah? Because we have to put the 2 zeros after the 100 until we get to the decimal place. Otherwise, it won't look like 35,000. So back here, I'm going to write 35,100, okay? And then it was the B value, I'm going to pop in here, which was minus, flicking back. And because I've asked for 2 significant figures, I'm going to do the same for the, no, what did I say? 3. I'm going to do the same for B. So what would B's 3 significant figures be? It'd be minus 3,940. So it'll be minus 3,940 times, and then I put the explanatory variable, which is the age of the car. Sorry, I'll probably put a gap in there. The age of the car time in years. Yeah. Okay. So there's me writing out. Sorry, I'm just going to take the underline off. That's me writing out the equation. Now it wants me. We would then interpret the coefficients. So the coefficients are the A and the B value. So if we go down here, now this is your template. You must just follow this and we can never not get the mark, okay? The examiners are happy with this. So what you can see, the yellow is what you need to change in terms of your scenario, and so you just need to plug it in. So if we're looking at it, we're first going to interpret the slope, which is the B value. Now, in my example, my B is a negative, so I'm coming down to this one where it says negative, and this is what I would be writing out. I'd say the slope estimates on average now we have to put the RV, so for me it would be price, so price would be put in there, decreases by the B value, so which we said, see how I don't need to write negative, the word decrease is indicating the negative. And what did we say? We said 3940, I think. Was that right? So 3940. Now, it says that the RV units. So it was dollars, wasn't it? Price. So it reduces by $3,940 when so we might put that in there, or you might just have the dollar symbol. When now the EV, the age increases by 1 and whatever it was measured in, which was years. Okay, so does that make sense? You would just fill that one in. So I'm just deleting that out. So that is, so that's how you do it. You just have to follow that template, and then we're all good. Okay, yeah. So then if we're asked to interpret the A value, which is like the intercept, we would write this paragraph, and it says the regression line intercept predicts the average value of the price of the car price, price, to be the A value, which was, I think, what was it, 35, what did we say? 35,100. When the age of the car is 0. So when it first drives out of the car yard, they were saying it was 35,000. This is an example of when the intercept would be interesting, because we say before you drive it out, it's 0 age, yeah? So that would be in. So the interpretation of the y-intercept in the data context can be meaningless. So in terms of yesterday when I said, say, if you want to write down in there, sorry, because I'm not on the laptop, you might say, for an example, weight versus height is an example of when the y-intercept would not be appropriate. No one is ever 0 height. So that would be, so even if you write no one ever is 0 height, you can pop that in, okay? So, but this example with the cars and that, yes, it is relevant, because a car before it drives out. So here, we've done all this, interpret the age. So the examples in there, so you could maybe write that out later underneath that, using those templates. And then we're on to the next bit where it says using the regression line to make predictions. So here's our regression line here, and they're saying we now use it to make a prediction. So it says use your equation to predict the price of a car that's 5.5 years old. So all you have to do is pop in 5.5 into your formula and get it. So if I think I did this earlier. Yep, just here. So I've typed that in, and I predicted the car to be 13,430, okay? So using that formula. All right, then moving on, what we would do when we make predictions, we like to say whether it was interpolating or extrapolating. So what interpolating means is that you have predicted within your data range. So I'm just going to zoom in a little bit here. So if, oh, what did I do? Oh my God, I went way back. Sorry. Where am I? Back here. Sorry. When I zoom in. Oh, don't do that. Yeah, it doesn't like me doing that. So anyway, when we predict within the data range, I might just go to the graph here. Let's go to the scatter plot. So if you predict, see my first age was 1, so your first dot's on 1 and your last dot is on 8. If you predict anywhere in between those values, it's interpolating. And it's more reliable. And why is that? Because we can see what's happening in those years. We've got some data to say that. So if you predict within, now it's not necessarily 0, it's just whatever your first one is. So our first one was a 1 and our last one was an 8. So it's sort of your range, in between the range, the minimum. If you're in there, it's interpolating and it's reliable because we can see what's happening around those years. If you predict outside, so if I predicted a 0, I'm actually, it's not reliable because we don't really have data. And if I predicted after, say the 9, 10, or 11, it's not reliable. And so that is called extrapolation. So if we go here, so predicting outside is called extrapolation and it's not reliable. So you'll see questions in there where they talk about, is your prediction reliable? And this one we did was yes, and you would say yes because it's interpolating, and you might write a little explanation as we're predicting within the data. Okay, so that's interpolating. And then our next part of our regression analysis was we needed to do the R squared. So we got the R squared, we've already got it, and I've repeated the blurb. You must write this blurb. So I think if I go back, I can't remember what it was. So our R squared value was 0.92. I'm going to say, I'll do 3 decimal places. So 92, oh, well, what's that going to be? 930? Or 930, yeah? So I would say if I did this, the coefficient tells us, now we said 0.930, so we just say 93%, 93.0% of the variation in, and this is where I'd write price, is explained by the variation in age, okay? And that's how you interpret the coefficient. And these words variation you'll see in questions. They might say how much of the variation in price is due to the age, and you'll know that's a way of asking the R squared value. Okay, so we've done all that. Now we get up to this residual plot. So I said the residual plot is assessing whether it is actually linear, because we have assumed. We've just had a little look at it and we reckon it was. Okay. So remember, I said the residuals were those distances between what the line suggests it is and what it actually is. So remember we talked about that the other day. And so what the residual plot is we're going to plot all those residual values on a set of axes. So for every age of every car, they had an age, we'll use that, but instead of putting their price, we're putting their residual value. So what you have is if your predicted value was is higher than what it actually was, you'll get a negative residual, and if your predicted value was lower, you'd get a higher. That's why we see when we do these graphs, we have a 0 line. So some of them, if your predicted was exactly what your data value was, then it would be on that 0 line. There's no residual. All right, so you can be asked to calculate an individual residual. So if you look here, it says calculate the residual for a 6-year-old car, which was whose actual price was $6,500. So here you would be typing up or writing out residual equals actual minus predicted. That's the formula. And then what you would do is, so the actual was 6,500. Then you're going to minus. The predicted is when you use the equation. So I'd have to pop in that equation again, and it will be times the 6 because it's a 6-year-old, 6 years. And then when you do that, I think I've done that on the calculator too. Here, so when I type that in, its residual is negative 4,960. So it was negative 4,960. So that one, if you were on a residual plot, we're going to see that dot, the 6-year-old car. Oh, there it is. You can see it there in the little diagram. It's down there. That's the negative 4,900. So we need to be able to do these residual plots on our calculator. So, but just before we go, we'll talk about it and we'll see if our one does this. So a key assumption made when calculating the equation was that it was linear. Now, if the original scatter plot is linear, in your residual plot, you'll see no pattern. So this is the original scatter plot here, and this is the residual plot next to it. And see how the dots in the residual plot are random. There's no pattern, they're everywhere. When that happens, you can say, yes, we were right, it was linear. If it's nonlinear, so I put an example here. Can you see how the original scatter plot has a little bit of a curve to it? So even though we thought it was linear, so we went on and did it, but it has a curve. And what happens when you do the residual plot, can you see how it has that upside down, or it has like a parabola look in there? Can you see that? It's not random. So when that happens, we say, no, it wasn't linear. We say non-linear, okay? So let's go look at how to do it on the calculator. Instructions are there, but I can do it with you. So we're going to go back to our scatter plot. I'm going to draw it again to work it with you. So we've got our scatter plot. So we put price and we had age. Okay. To get a residual plot, you must put that regression line on this scatter plot because the calculator won't calculate the residuals otherwise. So we're going to press menu again, analyze, regression, and A plus BX. So we must have that there. Once you've done that, then you'll have the option to get the residual plot, which is menu, analyze, and see down here there's residuals. And the second one, show residual plot. And if you do it, it's got the original scatter plot up the top and the, this residual plot down the bottom. Now, it shows random. There's no little pattern in there. So I'm going to say this data was linear. And if you look over here, there was 6 years. We didn't round. So when they did this one, they didn't have the rounded equation. But there's our negative. You can see this one, the 4-year-old car, they predicted pretty close. They're only 100 and a bit off. And so there is all the residuals. So we would see how we had 15 data points along here. See how the 8-year-old car, it had a residual there, 547. So they've all got their residuals in there like that. All right, so we went through that, and that does that. I know I'm going to stop there now. Sorry. Oh my God, just stop, you stupid.